Football isn't just about strength, speed, or strategy. It's also about math, more specifically quadratic functions. You may not realize it, but whenever you see a football punt, field goal, or pass, there's a hidden math equation behind it, shaping how the football flies through the air. Today I'm going to show you how quadratics help make some of football's biggest plays possible.
Quick throw. Intercepted. Van Ginkel. Down the sideline. Touchdown. Another pick six for Andrew Van Ginkel.
But you have to take the situation in the game into account, which the analytics doesn't do.
So a new set of downs for Andy Dalton and the Panthers. Here's Hubbard up the middle, still going, inside the 20. Chuba Hubbard takes it all the way for a Carolina touchdown, 38 yards.
These two guys are going to be matched up in a lot of man coverage all day.
Looking that direction, here comes pressure again. Two Browns ran into each other. Daniels uncorks a deep shot. It's McLaurin inside the 5.
Patriot offensive line held up well there for Brissett to scan the field. Stevenson stays in, turns the corner. And Stevenson working his way downfield, all the way into the end zone. That's a Patriot touchdown for.
Why don't you smile more out there? I get locked in. I am becoming more aware of where the camera is at all times. Deep shot, Stroud. Nico Collins is gone! Touchdown! Houston! 67 yards on the bomb!
But Ken Lawrence get them into the end zone. Put some air under it. Far side. He's got Thomas wide open. Thomas! Touchdown!
You may be wondering, what exactly is a quadratic function? Well, and how are they related to football? Well, a quadratic function is a type of mathematical equation that describes curve, like one you will see when a football is kicked, thrown, or even punted. The basic form of the quadratic function is y is equal to ax squared plus bx plus c, where y represents the height of the football, x is the distance, and the other parts a, b, and c help control the curve. Quadratics describe the motion that starts at one point, rises till it peaks, and then falls back down. It's the shape of almost every football thrown, punted, or field goal attempt. Today we'll break down the three key parts of football: punting, kicking field goals, and throwing passes.
Meanwhile, Flacco is 8 for 27. Herman's going to let the punt go, and do you stay out of the end zone? Break it first.
Well, it's at least touched there, so they shouldn't mark it back on the half-inch line.
Over the head, will it find the end zone, though? Dying, and again, the value of Thomas Morstead. He's unbelievable.
It's just a chip and a punt. That right tackle position is going to be important for them.
Yes, it is. Marquette King sails one down to the 3, sideways bounce, and covered up by Patterson at the 1.
Second in net in the NFL this year. Bearcat signal made, and will it be stopped at the goal line, trying to keep the toes inside the line and keep the ball.
When a punter like Johnny Hecker launches the ball, he is using the power of physics and quadratics to send the ball flying. Punting involves kicking a ball at an angle, which means we're dealing with two things: speed and trajectory.
Special teams have been rock solid for the Rams so far this year. They did have the two misses, but both misses, like you said, Charles, 55 yards away. And now trying to pin the Jets deep, and, well, you can't do it any better than that.
They're going to try and get after Case Keenum.
Backer on the punt, Jalen Marshall, another rookie out of Ohio State, waits And a fair catch at the 14-yard line. I mean, there were a whole host of Jets there. This one punted. Chasing Jalen Marshall. He's had ball control issues all year long when he's been back there. There's a penalty flag down. Marshall, a pair of fumbles early in the year on punts that were returned then for touchdowns. This time it's Nick Marshall rather than Jalen Marshall back to return the punt.
Exactly, and the Jets left their defense on the field for precisely that reason, Tom. They played what we call punt safe.
Look at this punt. All the way back to the 5-yard line. And Jalen Marshall is struck down at the 14-yard line. That hecker is some kind of weapon. I mean, what a weapon he is. Jalen Marshall stands back at his own 25. And Hecker, high punt. And a fair catch made at the 23-yard line.
The path of the ball forms a parabola. If you ever seen a punt, you know it doesn't go straight up or out. It arcs in the air. The curve happens because of the force of gravity pulling the ball down after it kicks. The equation for this curve is a quadratic. Here's what happens. The A of the quadratic affects how steep the arc is. A is higher than A. Means the ball rises faster and falls quicker. The B controls the direction and strength of the ball's initial velocity. The C represents the starting height, which in Hecker's case is often higher because of his leg strength and angle in which he kicks. So when Johnny Hecker kicks the ball, the way it travels in the air flows the quadratic path. He uses this to make sure the ball stays in the air long enough for his team to get downfield and cover it.
27-yard attempt. Jeff Locke is the holder. McDermott is the snapper. And the kick is no good! Wow! Go figure.
With a 40-yard attempt for a win and a game to the Super Bowl. The kick, spotted kick, it's up, it's good! The New Orleans Saints have won the NFC Championship! They're going to the Super Bowl for the first time!
A 47-yard field goal try in overtime to win it. Snap. Sam Cook with a hold. Kick on the way. Kick is long enough. It is good! And the Ravens are going to the AFC Championship game. And the miracle has come to pass.
Now let's talk about field goals. Like the ones made by Younghoe Koo, kicking a field goal often relies on quadratics, especially when it comes in an angle or distance that a ball needs to travel.
After a run play on third down, Younghoe Koo, the kick is through.
Green Bay, his 8th career game-winning field goal already. One of the more reliable kickers in the game ties it up at 3 apiece. Kick, and Koo got it, and Atlanta wins it. Wait, there's a flag down.
There were 2 fouls on the play, both by the defense. Offside, number 25, this penalty is declined. Running into the kicker, also number 25. This penalty is also declined. The field goal is good. The game is over.
And Koo's kick is good. That's his 18th consecutive made field goal at home. They are out of timeouts. They lead by 7 on CBS.
When Koo kicks the ball, he has to think about how to make sure the ball gets over the defenders and through the goalpost. The height and distance of the ball when it travels are both determined by the quadratic equation. The A in the equation controls the steepness of the ball's path. If the angle is too low, the ball might not get over the defenders. The B helps determine the ball's initial speed, which is crucial to both distance and accuracy. The C is where the ball starts, usually from the ground or slightly raised depending on the holder's position. Ku's job is to control these factors to make sure the ball follows the right path and split the uprights. Math is behind this curve of the ball. The math behind the curve of the ball helps him understand exactly where to aim and how hard to kick.
Tagovailoa, play fake, Tua loads it, goes deep for Waddle, got him in stride. Waddle down the sideline, you can forget about it. Touchdown, Alabama.
He's not that wide open. He just delivers the ball right on him, right in stride. People don't do this kind of stuff.
2nd and 9. Daggy gonna take a shot. Scotty Miller's got it. Miller with speed. See you later. Touchdown. Scott Miller, 76-yard pitch and catch with Jared Daggy.
Juan Dallas on the outside man coverage, just a 9 route, and you see the speed of Scotty Miller. Boy, unbelievable throw and catch in stride.
Fakes it to Amsler, gives it back to the tight end, and Reeves throws a pass. Looking, touchdown Pickens.
Great call, the running game's been working. There goes Pickens, he kind of jogs down and then he beats the deep zone. And he just a great throw by Reeves here. You know, a tight end puts it right on the...
Now let's look at a quarterback. Carson Beck, for example, has one of the strongest arms in college football. When he throws a long pass, the ball doesn't travel straight in a straight line. It follows a curved path, like a parabola.
Minute of the third quarter. And the lob to the corner, and it's a touchdown to Dylan Bell. Perfectly thrown ball by Beck. His second touchdown toss of the day.
Ball down to the 27-yard line. Beck takes a shot to the end zone. What a grab. That's a touchdown for Cass Jones. There is a flag down.
They're going to motion someone over to take that double team off of him.
Beck, all kinds of time. Now he's going to run. Nice move into the end zone, touchdown. That's got to feel good for Carson Beck.
And a projected first-round pick is back in the mix tonight. But the Dogs getting healthy. Beck off the play fake, right down the seam. Caught for a touchdown by McConkey.
Here comes a Jackets blitz, well picked up by Edwards. A man is open. It's Lovett with the touchdown. They blitzed and did not get there. And Lovett has the score, his third of the season.
The same quadratic principles apply here. The initial speed shows the angle at which Beck throws the ball, determining how high and far it will go. If he throws the ball at a high angle, the ball will travel higher and come down at a steeper angle. If he throws it at a lower angle, the ball will travel farther horizontally, but not as high. And this is important. This is one of the only times that in football to where a quadratic function does not start in the ground but on the air. So the y-intercept is not 0. In this case, it's around 5, 6, cause like, if that makes sense. In between that range, 5 and 6. The key to a perfect long pass is knowing exactly how to adjust the angle and speed to make sure the ball lands in the receiver's hands. For Beck, A in the quadratic equation tells him how steep or shallow the arc will be. The B affects the distance, while C tells him where the ball starts from, like the height of his hand when he releases the ball. Important because unlike when you're kicking a field goal or punting, the ball doesn't start at 0 on the ground or a couple inches off the ground. It starts in his hands, which is between 5 and 6 feet. In other words, Beck's throws follow a quadratic path that allows him to launch the ball deep downfield, giving his receiver the best chance to catch it in stride. As you can see, quadratics are everywhere in football, from punts to field goals to long passes. But the amazing thing is, these same principles apply to many other sports too. In basketball, for example, when you shoot a three-pointer, the ball follows a parabolic arc. In soccer, a well-placed free kick curves through the air and thanks to some kind of quadratic path. Even in baseball, when a batter hits a home run, the flight follows a similar curve. In every case, understanding the math behind the trajectory helps players improve their skills. Whether it's punting a football, shooting a basketball, or hitting a baseball, quadratics helps athletes control the path and make precise shots. So next time you watch a football game or any other sport, think about the math that's happening behind the scenes. Quadratic functions are what make the amazing kicks, throws, and shots possible. They are a reminder that math isn't just about numbers on a page, but it's also about the real world and helping athletes perform at their best. Thank you. And remember, math is everywhere, even on the football field. When you see a great play in sports, remember, math helped make it happen. Quadratics might just be the unsung hero behind the game.